Without further ado, I'd like to invite Mr. Adam Elman, Google's Director of Sustainability for Europe, the Middle East, and Africa, and our host institution's own Dr. Vangelis Karkaletsis to take their seats. Adam, Vangelis, the floor is yours.
Okay, we continue. Adam, it's really great to have you here with us. Just a few words about Adam first before we start. Yeah, from your profile at the site of the Lyceum Project. So Adam Elman is the Google's Director of Sustainability for Europe, Middle East, and Africa. He's a sustainability leader with over 20 years of experience. He works in the intersection of physical, digital, and natural worlds, and many, many other things. Okay. Adam, it's really great to have you here with us today. So, in the previous sessions, we've heard about Entangled Intelligence, we heard about Animate Intelligence, with for ecosystems intelligence, and also about how we can use animate intelligence to develop new technologies, as Manolis presented just before. Now, in our discussion, we're going to talk about AI for nature. What AI can do for nature. What can AI do for nature?
Great question. Well, look, thanks for inviting me and for partnering with Google. I know we've been a partner of this for the 3 years, and very excited to be a partner. So, look, at Google, we very much think that AI can be harnessed to help deal with some of the biggest issues that we're facing, including the planet and people living on it. And, you know, that ranges everything from sort of education through to health and sustainability. It's actually the reason I came to work at Google. So, you know, I'm sure we'll get on to some of this, but we spend a lot of time thinking about how we make our own operations sustainable, but how can we harness AI and to enable everyone else to make progress. And absolutely, when it comes to nature, there are a number of ways where AI is already having a big impact. And I think one of those areas is around data. We have a lot of data, and data is great, but actually just having data itself sometimes isn't helpful. You need to be able to get insights from that data. And that's where AI can be a really powerful tool. So one example is a platform called the Wildlife Insights platform, which is developed by Google and a number of partners in this sort of NGO space. And this particularly focuses on camera traps. So how do we take these camera traps? How do we get that imagery? And there's lots of it, but again, it's not necessarily helpful. And there's an AI model sitting behind it called SpeciesNet, which is developed by colleagues in Google DeepMind, that basically trawls through all of this camera trap imagery. It takes out all the empty frames, it identifies the frames with animals in, and it helps identify what those animals are. So something that would take many, many, many hours to do manually, and really does that in many seconds. And that's then giving, organizations around the world that intelligence to be able to do things and check on the sort of health of the ecology.
So use of AI for monitoring then, eh?
For monitoring, yes, for monitoring and really speeding up and helping to provide those insights. It's really interesting. As I say, the platform's been operating for a number of years. We actually open sourced the SpeciesNet model last year. And there's all sorts of amazing case studies that have come through already. There's a project in Africa, a Serengeti project, that had around 10 million images that they collected over the last 10 years and really had done nothing with it. And SpeciesNet's processed it within a matter of days, giving them all that insight, that rich intelligence to understand the health of the ecosystem and sort of what to do there.
It's necessary to collect data, but you need to do something with them, eh?
You need to do something with it. And, another example, we have another model called Perch. Perch is all about basically bioacoustics, particularly for birds. Again, trawling through all of this bioacoustic data, helping to identify birds. There's a great example of an initiative in Australia, in Melbourne, where they used it and they were able to identify an endangered species that hadn't been identified in 30 years. And they were able to find out where it was thriving and again, put in place additional work to help it thrive. So yeah, making sense of data is where, in particular, it has a really helpful role to play. But I think another thing that's really important to think about is actually how do we democratize access to this data? So again, often this data has been in the hands of real specialists, so data scientists, computer scientists that know how to use the databases, know how to code. But actually AI increasingly is making this really accessible, so we can stick natural language models over the top of it. And everyone can just ask really simple questions. And actually, I tried this before. There's a platform with WRI. WRI is actually the partner we did the paper you mentioned with. The platform's called Global Nature Watch. Well worth checking out. I went onto before, and I just asked the question, tell me about tree coverage and tree loss in Greece over the last 20 years. So I asked a simple question. Within a few seconds, it brought up all the data, it brought up all the maps, showed me all the imagery, and I said, well, give me some stats. And it told me, since 2021, 315,934 hectares of tree coverage loss in Greece, 30% of that in 2007, 2021, and 2023.
And this is accessible by anyone, eh?
This is open source and accessible by everyone. And then I asked it, well, what's caused that tree loss in those 3 years? And it said it correlated it with the wildfires. So again, it's not only just making sense of the data, but it's making it accessible so that everyone can use it.
Okay, I see. So two of the breakthroughs that artificial intelligence can bring for nature is collection of data, integration of data in platforms, okay, and enable the accessibility to data, not only for specialists, but also for all the people. Yeah.
And I should say, when we talk about data, and this was sort of mentioned in one of the previous sessions, there is a lot of, call it technology data, so, you know, satellite imagery, photographs, audio recordings, all those sorts of things. But actually, there's a much broader data set we need to bring in, so that sort of indigenous knowledge as well. And increasingly, again, there are some fantastic AI models that are allowing indigenous communities to just orally dictate the knowledge that they've got, bringing that into the platforms as well. So we get this much richer data set. So it's really important that we have all of this knowledge, human knowledge, along with the digital knowledge as well.
Okay, and how about exploiting this knowledge? Not just asking questions, answering to questions like the ones you raised, but using this knowledge in order to find solutions. Can AI, artificial intelligence, help to find solutions for nature instead of just monitoring and accessing?
Yeah, so absolutely. So I think historically, for many years, you know, and AI is not new. And for a long time, AI has been very good, as I say, capturing this data and making sense of it. But I think as we look to the future, one of the really exciting things is about AI and its ability to forecast and look forward into the future. So one example is with forests and trees. So for a number of years, if you've come across Google Earth, we've been capturing satellite imagery going back 4 decades. And you can go back and you can look at decades worth of satellite imagery. And that's helped us to understand what's happening in terms of deforestation. And we've put that in the power and, you know, into sort of governments, into NGOs, and businesses are using it. You've got organizations like Unilever are using it to monitor their supply chain so that they can ensure that deforestation isn't taking place. So that's great, but increasingly AI is going to help do forecasting as well. And actually we've launched a model called Forestcast, which does that. It looks at the historic data to predict where deforestation is going to take place, so that actually governments, NGOs, communities, businesses can take action even before the damage has occurred. And that's been released now, and again, that's open sourced as well. So yes, increasingly it's going to be used for prediction. But I think more broadly, the technology is moving really, really fast. So another area we've focused on is flooding. So flooding is a really big issue in terms of communities, but it impacts on nature, impacts on communities, impacts on livelihoods. And we, for a number of years, have been using AI to predict riverine flooding. And we combine the AI model with local data. A lot of rivers have gauges, so we can use that to predict riverine flooding. We can now predict riverine flooding in about 150 countries around the world up to 7 days in advance. Up to 7 days. So that's allowing people to take action. In fact, it's so good now that there are NGOs like Give Directly who are so confident in the data, they're giving aid money out in advance so that individuals can protect their home or protect their assets or sort of get away. But we've been running that for a number of years, and it's been very successful. You can look it up, by the way. You can just Google Flood Hub, and you'll find it for yourselves. But actually, a lot of mayors, governments reached out to us and said, this is great, but actually one of the big issues we're dealing with is flash flooding increasingly. So in city centres where just heavy rainfall. The problem with flash flooding is there isn't that historic data source in the way that we have with rivers. So our team's developed a new model which we released a couple of months ago, and the first use cases for flooding. And so this ground source model actually trawls 40 years worth of public data. So think about local newspapers, major newspapers, think about social media, and it's trawling all that information for information about flash flooding. And with that data source, it's now able also to predict flash flooding as well. So again, the models are just getting smarter as we think about how we can capture this data and how we can use this data.
So using more historical data plus citizens' science data, and it can increase the accuracy also of these predictions.
Yeah. There's also some really exciting projects that we're running and others are running to crowdsource data as well. So there's one called Forest Listeners. There's also one called Calling in Our Corals, where basically individuals can go. Again, we have all of this data. Individuals can go on and we teach them, we train them how to spot different sounds. And we're crowdsourcing. Millions of people around the world are going in and starting to say, I heard this sound, I heard that sound. So it's being used to identify when coral reefs are healthy, when forests are healthy. So again, we can crowdsource human intelligence as well to help train the model.
So the main problem in that case is collection of more data in order to be more accurate, the models. Because you know, in Europe, for instance, okay, there are several initiatives around the environment, around sustainability, using AI, but a lot of them are rather fragmented. There are many data sets all around. How do you handle this problem?
So exactly. So there are a couple of things. We have huge amounts of data sets, and again, you need to take the sort of the nature data. You need to put that alongside population data. You need to put it against weather data. And AI is really good at looking across these multiple data sets and being able to make sense of them. And putting them again in the hands of local experts as well. So, you know, if you're going to make a local decision about, you know, an infrastructure change or an investment or some protections, you want to make sure you're making that right decision. Again, the models are putting all of these different data sets to help make sure those decisions are likely to have a positive impact. So yes, we need to combine the data sets. As I mentioned earlier, we need to keep thinking about those new types of data sets, and we need to democratize it so that it's not just in the hands of a few. I think the other sort of really interesting thing that we need to think about in this as well is where are those data sources coming from? So historically, there's been quite a lot of this data in the global north, where we've had more technology around for a long, long time. So there is a risk in here that the data sets get skewed because they're not representative. So again, one of the things we think about, and when I talk about we, most of the things we do at Google are in partnership with others. Every single project I've mentioned so far is working with other players, working with the NGOs, working with governments and what have you. And so again, we very much think about where those data sets are. So how do we make sure that the data isn't skewed, that it's representative? But again, as the models are getting smarter and smarter, we're finding that even when those data sources don't exist, the models are highly accurate. So when I was talking about flood forecasting before, in the early days, it was very accurate in the global north where we had the data sets, but in other parts of the world, it just wasn't accurate. Actually, we're now seeing it's highly accurate because there is enough data to roll out into these regions as well. So yeah, we need to make sure that the data is representative.
How about explainability of the models used in order to process this data.
Yeah, it's a great point, because we don't want these to be black boxes. And again, this is where sort of the natural language overlays are being really helpful. So one of the examples I like, there's a tool called iNaturalist. I don't know if you've seen it. It's an app. It's an amazing app for just individuals. You can just literally take a snapshot of nature, whether it's plants or animals or what have you, and it will help identify them and tell you what plant it is and sort of give you information. But actually, as the models have got smarter now, it's starting to provide a lot more context. So not only will it say, actually, it's this bird, it'll start saying, well, it's this bird and I've identified it because it's got this particular marking, or it's got this particular sort of cell structure visible on the leaf, or whatever it may be. So yes, increasingly we want to provide a lot more information. And again, being able to go and ask information. The example I gave earlier when I was asking for forest coverage, I asked one question, I go, that was interesting, I want to know more. I dug into it. Why was there so much damage in those particular, there was a fire, right, tell me more about it. So yeah, we need to provide a lot more context, because, again, we want people to ask the right questions, we want people to be able to dig in, we want people to think about what are the actions that they can take to, to advance and, protect nature or whatever it is they're trying to achieve.
From all these things that we have said about the future of artificial intelligence for nature, what do you think it is one of the biggest priority, or you consider the biggest breakthrough for the future, in order to facilitate all these nice things that we are talking, accessibility, integration, explainability, all these things?
Yeah, and look, this is so important. Half of GDP is linked to nature. It's directly related to nature. So this is a financial issue as much as it is a sort of planetary issue. And I think that we've somewhat touched on this. I think the two things that I'm most excited about are, one, everybody be able to make sense of this data. Everybody on the planet being able to use it to make insights, to take action. And second, as I say, is this shift away from just backwards looking. It's great we can look at what happened in the past. That helps us to think about the future. But how do we really start to think about and predict into the future? And what's really interesting now is we're seeing, as I say, we're seeing governments use this to make policy changes. You gave I think, an example earlier in Ireland, who are using this for a different case study, but they're changing policies around infrastructure to improve cycling. We're seeing NGOs change their investment strategy. We're seeing this in industry as well. The insurance industry, the finance industry, really starting to take different decisions about their investment. So I think the power is going to be in predicting the future and really informing, so we can be confident that those changes we're going to make are going to have a positive outcome.
So you think now we have all the components, all the building blocks in order to exploit as much as possible AI for the future?
I think we have a lot of them. I think
have a lot of them.
The technology is moving really quickly, and it's really exciting. And we were chatting about this before. My big fear, and I should say as well, like, AI is not the silver bullet. AI is another tool in the toolbox. And one of my colleagues says AI can do a lot for the planet, but only humans are going to save it. And I think that's absolutely true. This sits alongside individuals, around policy, around investments, many things. But yes, we have a lot of solutions. But my big fear is that if they don't get deployed, if they don't get used, if they don't get scaled, then they're not going to have the impact. And I think the technology is moving really fast. Historically, organizations are not great at that technology transformation. So, for me, I'm running a big event in London next week, which is all focused around getting everybody a better understanding of what the technology can do. So that's my big fear, is we have solutions, but if they don't get used, then there's no impact.
So it's the combination of human intelligence and artificial intelligence. Eh?
If we're throwing out all sorts of words now, but I like to think of artificial intelligence as augmented intelligence. It's another tool in the toolbox. It's a really powerful tool, and it's allowing us to do things that sometimes just weren't even possible before, or just speed up things in by tens of multitudes. But yeah, this sits alongside many other things. But it is a really powerful tool, and it's having an impact today. So this is not a future promise.
And you mentioned something before. How about risks and for all these and challenges for all these application? You mentioned the issue of the data sets and that we do not have representative data sets for different areas. Any other risks that you consider important for the use of AI for nature?
Yeah, look, I think having the right data is important, making sure it's representative is important, making sure everyone has access, making sure it's secure. Again, you know, for Google, people often ask us about information sets. Like, we buy a lot of information. We have to protect it. We can't give, you know, so obviously making sure privacy, all of those obvious things. I guess the thing that I get asked a lot about is about the infrastructure. It's great we have this AI technology, but there's a cloud, and this cloud is powered by data centers. Those data centers use energy, they use water, they use resources. It's great we can have a positive impact, but if it's having an equally bad negative impact, then we have a problem. So we spend a lot of our time making sure that we're focused on our infrastructure as much as we're focused on the solutions. So, and we think about that in a number of ways. And we're quite unique. We're a full stack player, so we develop our own models, but we also develop our own hardware as well. So the first thing we think about is efficiency. So, you know, our models are getting ever more efficient. We published a full, if you like, life cycle assessment of Gemini, which is our sort of core foundational model, and we were able to show over a 12-month period that it got 33x and 44x respectively from energy and carbon more efficient over a 12-month period. So the models are getting more efficient. As I mentioned before, we build our own chips, our own silicon, what we call tensor processing units. These are chips specifically designed for AI. Our latest chip, Ironwood, is 30 times more efficient than our first chip a number of years ago. So the hardware is getting more efficient. Putting that all in perspective, compared to 5 years ago, we have 6 times as much compute power for the same amount of energy. So we're getting super efficient, which is great. That's not good enough. We need to make sure that we're powering our data centers with clean energy. Last year, we were the world's largest corporate buyer of clean energy. So we're investing in tens of gigawatts worth of sort of wind and solar. But actually, we need to invest for the future as well. So we're also helping to develop the newest forms of clean energy, whether that's small modular nuclear reactors, advanced geothermal. We've even done the first corporate deal for fusion. It's obviously not powering our data centers today, but we think these are important bets. We're also not just trying to solve for ourselves. If we're the only company that can run on these sorts of clean energies, then we failed. We're in a privileged position. We can do some of that innovation, some of that investment that hopefully brings down the costs and expands the technology so everyone can benefit. So yeah, really making sure that the infrastructure is efficient as possible. Just to put this in perspective, in 2024, just 5 of our solutions saved 26 million tons worth of emissions for other people. That's well over double our own emissions. So, you know, one doesn't counter the other, but we need to keep focusing on our own operations, but we're super excited about the role AI is going to play for the climate.
But still, we need more computational power and more computational power. Now in Europe, we have the initiative of the AI factories. This was mentioned by the minister before. And now we have another initiative, the giga factories, okay, big data centers that will consume more power. So do you consider this as the biggest challenge for the use of AI?
I'm the sustainability guy, so that's what I focus on. Yeah, I mean, it's a huge challenge, but if it's done right, it can be done well. You know, and again, I'll give you an example. In Finland, we have a data center in Hamina. It runs on 97% carbon-free energy. That means locally sourced clean energy matched on an hourly basis, 24/7, every day, every hour. So it runs on clean energy. It's cooled using seawater. We actually then use the heat from the data center we give for free to the local community. It covers 80% of their needs for free. And again, that's 97% carbon free. So it's a great example when you can power a data center the right way, you can support the local community from an environmental perspective, lots of other benefits in terms of jobs and other things as well. So it does, you can do it, but you need to be very thoughtful about it. And we at Google have been very public. We have these ambitious moonshots. We've said we want to be net zero by 2030. We've said we want to run on 24/7 carbon-free energy. We want to replenish 120% of the water we use, et cetera, et cetera. So yes, you do need to be thoughtful about it. Otherwise, it's going to be a problem. I think we're showing that, we're making good progress. We don't have all the answers. And this is a really hard challenge. But we like a hard challenge.
And how about I return to a thing that we have discussed before, the underrepresented areas. What are you thinking? What sort of solutions are you thinking in Google about this?
This is very much about partnerships, and I touched on this before. So much of what we do is partnering with others. So we partner with NGOs, we partner with governments, we partner with cities, with community groups, other businesses, other industries. And so, again, for us, that's a bit of an unlock. But again, Google can't solve this alone, right? We need the right policies in place, and we spend a lot of time talking to policymakers. There are a lot of data sets that exist out there that should be made publicly available. They should be structured in a way that can be useful. So again, I think we're trying to do what we can do, but we need to partner with the whole ecosystem.
Networks and partnerships then, huh? Okay. So we have just a minute left. Maybe one question from the audience? Yes? We need a microphone.
I'm a physicist and an experimental one at that, and one question that occurred to me is, in physics, we have a model, and then we have a prediction, and then we design an experiment to, for example, verify the prediction. The perihelion of Mercury's prediction of Einstein is well known, and so on. What is the predictive capability of AI when it comes to big social problems? And it's one that I could have asked in the last session as well. In other words, there is this business of job loss throughout the economy worldwide. Can AI sort of look at itself and see what it's going to do to society? And it may give us a prediction.
And I should say I'm 3/4 deaf, so I only caught a bit of that, but I think it was about predicting more broadly outside of sort of sustainability. And look, I think even in the sustainability space, there are different capabilities in terms of how far out you can predict. We spend a lot of time on, again, working on all of these sorts of topics. So I think a good example is actually working with the UN on things like the SDGs, which obviously looks at the sustainability side of things, but it's looking at livelihoods and topics more broadly. So the UN has masses of data, but it was very inaccessible. So they've worked with us on a solution called Data Commons. You can search SDG Data Commons, and now you can mine all of the data from the UN. So if you want to say, I'm interested in weather patterns combined with migration, you can access that data and start to then use predictive models on top of it. So on any particular topic, the sort of how far out you can predict and how good that prediction is will be very different. I think what's important, again, this is why we work very closely on things like with other meta agencies on weather data and specialist organizations on particular topics to actually test these models and make sure we're figuring out how good those predictions are, because they're never going to be 100%, and obviously things are changing all the time. So yeah, I think there's lots of opportunity, but different topics are going to be in sort of, I guess, in different places in terms of how far out and how advanced they are at the moment. So not sure if that answered the question, but happy to chat afterwards.
Maybe one final. Angie? And we conclude here.
Thank you. You were saying how much more efficient the hardware was becoming. Earlier this afternoon, we were hearing about the importance of redundancy. So how do you square the redundancy versus efficiency?
Yeah, and It's a great question, and you've got to remember though that the cloud it's powering economies, it's powering hospitals, it's powering governments, all these sorts of things. So we have to build our systems so that they are they can run 24/7, because the risk is that that it has a huge impact on society. But we still need to think through that in a really efficient way. And so how do we make sure we're using resources efficiently? So again, this actually is the way AI is helping. I mentioned before our goal on clean energy. We have a model called carbon intelligent load shifting, and it basically says what are the compute jobs that we need to run tomorrow, and what clean energy is going to exist around the grid tomorrow at particular times of the day. And it will automatically shift jobs around to where the clean energy is already being generated. So I think that's just one example of how we make sure resources are being best used. There's a long conversation we can have about hardware, what happens at end-of-life hardware, circularity, all those sorts of things. So yeah, we need to be, and we are being very thoughtful about this. Things are moving very quickly though, so this isn't like, we don't have all the answers, but we're being very thoughtful about it.
Okay, thank you very much. Let's thank Adam. Thank you very much.